So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea, but sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests, widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned.
It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum. And that's at its highest pitch, all because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams' alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens, After all, past eruptions have only led to lava flows that travel just a few miles from the volcano, so that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic Basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news.
The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November, 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project, named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, Compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long, long nap. In 2021, scientists were sure it would happen soon. But so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up, or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, It makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tabo you already know about, Japan's Ericaldra, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption.
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal Volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yellowstone in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ali is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.